हेलो एवरीवन, वेलकम टू करियर पॉइंट। आज हम स्टार्ट करने जा रहे हैं इलेक्ट्रिकल मशीन का एक इम्पोर्टेंट चैप्टर दैट इज योर ट्रांसफार्मर। तो फर्स्ट टॉपिक टू बी कवर्ड, तो हम क्या टॉपिक आज कवर करने वाले हैं, दैट इज योर थियोरी ऑफ ट्रांसफार्मर। आज हम ट्रांसफार्मर का कुछ थियोरी जानेंगे, उसके बाद उसका कुछ न्यूमेरिकल्स और स्टेप बाय स्टेप हम जाएंगे। तो पहला चलो शुरू करते हैं ट्रांसफार्मर। तो फर्स्ट स्टेप इज व्हाई ट्रांसफार्मर इज नेसेसरी। ट्रांसफार्मर क्यों जरूरत है हमको, पहला चीज है हमको ट्रांसफार्मर क्यों जरूरत है। तो एज यू नो द जनरेशन ऑफ इलेक्ट्रिसिटी इज फार अवे फ्रॉम द लोड सेंटर। हमारा घर से बहुत दूर, जितना भी दूर हो सकता है वहाँ पे हमारा इलेक्ट्रिसिटी जनरेट होता है। तो वहाँ से क्या होगा, इलेक्ट्रिसिटी ट्रांसमिट होकर आएगा लोड तक। तो जब भी मेरा इलेक्ट्रिसिटी जनरेट हो रहा है तो इलेक्ट्रिसिटी जनरेट होगा वो लो वोल्टेज में जनरेट होता है, बट द ट्रांसमिशन line voltage is very high. So to convert a low voltage to a high voltage, transformer is necessary. Again, जो भी मेरा घर में जो मैं इलेक्ट्रिसिटी यूज कर रहा हूँ उसका क्या है, वो है मेरा लो वोल्टेज दैट इज 240 वोल्ट 3 फेज और 230 वोल्ट सिंगल फेज। तो उसके क्या होगा, जो ट्रांसमिशन लाइन वोल्टेज है वो मेरा हाई वोल्टेज है, बट मेरा डिस्ट्रीब्यूशन लाइन वोल्टेज मेरा लो वोल्टेज है। तो टू कन्वर्ट high voltage to low voltage we require transformer at the lower end. So transformer is necessary for both in generation end or for both in lower end in the substation or in the grid. Next is features of transformer. Transformer का क्या features है? Transformer, as you know, transformer is a device which convert electrical energy from one circuit to another circuit without change its frequency. तो इसमें क्या होगा, इलेक्ट्रिकल एनर्जी कन्वर्ट होगा वन सर्किट टू अनदर सर्किट बट विदाउट चेंज इट्स फ्रीक्वेंसी। सो पहला पॉइंट है ट्रांसफार्मर इज ए कांस्टेंट फ्लक्स डिवाइस। उसमें क्या होगा, फ्लक्स चेंज नहीं होगा। जो भी मेरा एक सर्किट में अनदर सर्किट से इलेक्ट्रिक एनर्जी कन्वर्ट होगा तो क्या होगा, फ्लक्स मेरा चेंज नहीं होगा। इट इज ए कांस्टेंट फ्लक्स डिवाइस। सेकंड वन इज इट इज ए कांस्टेंट पावर डिवाइस। पावर मेरा चेंज नहीं होगा क्योंकि यू नो देयर आर टू टाइप्स ऑफ ट्रांसफार्मर, दैट स्टेप अप ट्रांसफार्मर और स्टेप डाउन ट्रांसफार्मर। फॉर स्टेप अप ट्रांसफार्मर इफ voltage increases current is decreases, P is same. For step down transformer voltage is decreases but current is increases, power is same. So it is a constant power device. Transformer is a constant power device. Next is it is a constant frequency device. As you know, frequency cannot changes from primary to secondary. If the electrical energy changes, frequency cannot changes. So it is a constant frequency device. Next is the winding of a transformer is electrically isolated but magnetically coupled. So refer to the figure. This is the figure of transformer. Here this is my electrical circuit. This part is your electrical circuit. This part is your electrical circuit, but this is your magnetic circuit. So the winding of a transformer is electrically isolated but magnetically coupled. Next is it is a phase shifting device. Transformer is a phase shifting device. So for single phase, you know, it is a 180-degree phase shift, but for three phase there are different type of three phase transformer, that is your star star, delta delta, star delta, zigzag. The phase shift is 0 degree to 180 degree, but for star delta or delta star the phase shift is plus minus 30 degree, that is for 180 degree plus minus 30 degree. Okay, so transformer is a phase shifting device. Next is number 3 is it is a single excited device. As you know, the energy is given, single energy is given, not double energy is given. So it is a single excited device. Third point is transformer is a negative feedback circuit because it obey Lenge's law. it will obey Lenge's law, so it is a negative feedback device. Fifth is, it is a 4-terminal 2-port network. Transformer is a 4-terminal 2-port network. So you see, this is your 4-terminal 2-port network. It is a ABCD network. ABCD network. So you compare this figure to this figure. It is a 4-terminal 2-port network. So this is all about the features of transformer. Okay. Next we will discuss application of transformer. तो ट्रांसफार्मर हम कहाँ पे अप्लाई करेंगे? पहला चीज है, ट्रांसफार्मर इज अप्लाई टू चेंज द वोल्टेज एंड करंट लेवल बट पावर इज कांस्टेंट. मेरे को कोई भी करंट और वोल्टेज लेवल का चेंज करना चाहिए, तो मैं क्या करूंगा? ट्रांसफार्मर अप्लाई करूंगा. और ट्रांसफार्मर एप्लीकेशन है टू चेंज द वोल्टेज और करंट लेवल बट पावर इज कांस्टेंट. सेकंड एप्लीकेशन इज टू मैच द सोर्स इम्पीडेंस एंड लोड इम्पीडेंस. तो सोर्स इम्पीडेंस लोड इम्पीडेंस मैच करने का क्या फायदा है? तो देखिए, अगर मैं मैक्सिमम पावर ट्रांसफॉर्म थ्योरी के जाऊंगा तो उसमें क्या होगा ना, फॉर सोर्स इम्पीडेंस, फॉर मैक्सिमम पावर ट्रांसफॉर्म इन a circuit, if you flow the maximum power, then what is the condition? Source impedance is equal to load impedance, but efficiency is reduced 50%. अगर सोर्स इम्पीडेंस और मैं लोड इम्पीडेंस को मैच कर दूंगा तो क्या होगा? एफिशिएंसी मेरा 50% रिड्यूस हो जाएगा. इट इज ओनली पॉसिबल इन इलेक्ट्रॉनिक सर्किट बट नॉट इन इलेक्ट्रिकल सर्किट. तो इलेक्ट्रिकल सर्किट में सोर्स इम्पीडेंस और लोड इम्पीडेंस को मैच करने के लिए मैं क्या करता हूँ? ट्रांसफार्मर यूज कर रहा हूँ टू मैच द सोर्स इम्पीडेंस and load impedance by the use of transformation ratio, that is K is equal to root over of R2 by R1. Next is to use as a instrument transformer. तो पावर सिस्टम में मेरा इंस्ट्रूमेंट ट्रांसफार्मर का एप्लीकेशन है, दैट इज ए करंट ट्रांसफार्मर और पोटेंशियल ट्रांसफार्मर. फॉर करंट ट्रांसफार्मर एंड पोटेंशियल ट्रांसफार्मर वी यूज ट्रांसफार्मर. So these are the application of transformer. Next we will discuss what is the working principle of transformer. As you know, transformer is working as a principle of Faraday law of electromagnetic induction. So what is my Faraday law of electromagnetic induction? Is there is a relative space or time variation between a magnetic field or a conductor, then a EMF is induced. So to produce a magnetic field, to produce an induced EMF, induced EMF, which was necessary. There are 3 points necessary, that is a magnetic field, a set of conductors, or a relative space or a time variation between the field and the conductor. So if there is a relative space or time variation, जो भी हो, अगर space variation होगा और time variation होगा तो क्या होगा? एक EMF induce होगा between the conductor. So for this necessary 3 things necessary, there is a magnetic field, set of conductors, and a space or time variation between the field and the conductor to produce a induced EMF. So there are 2 types of induced EMF, that is for dynamically induced EMF or statically induced EMF. So there are 2 types of induced EMF according to the Faraday law of electromagnetic induction. There are 2 types of induced EMF, that is number 1 is dynamically induced EMF. Number 2 is statically induced EMF. So how dynamically induced EMF is produced? If there is a relative space variation between the conductor and the magnetic field, then dynamically induced EMF is produced. That is for your relative space variation. So dynamically induced EMF is used in DC motor or generator. For DC generator, dynamically induced EMF is used, and for statically induced EMF, if there is a relative time variation, then the EMF is induced in the conductor is called statically induced EMF. So in transformer, statically induced EMF is used, or statically induced EMF is produced. For transformer, statically induced EMF is produced, but for DC generator, dynamically induced EMF is produced. So for transformer, we concentrate about statically induced EMF. So there are two types of statically induced EMF. Statically induced EMF. For transformer, we will concentrate about statically induced EMF. So statically induced EMF, there are two types of statically induced EMF. One is self-induced EMF, and number two is mutual induced EMF. Mutual induced EMF. So there are two types of statically induced EMF. One is self-induced EMF, another is mutual induced EMF. Okay, so for statically induced EMF, I will take a coil. This is a coil which has n number of turns. If I flow a AC voltage V, this is my current I, then flux is produced. So here n is my number of turns, and what is my I value? I is equal to Im sin omega t. Then what is my magnetomotive force? That is your n into I. This is the formula of magnetomotive force. So this is your n Im sin omega t. Now what is the flux produced? Flux is equal to magnetomotive force by reluctance, that is equal to n Im sin omega t divided by r. So what is flux? Flux is equal to phi m sin omega t, because phi m value is equal to n. What is my phi m value? Phi m is equal to n Im by r. So this is my flux linkage. That is, flux linkage is equal to n into phi. So if flux linkage is n into phi, then what is my induced EMF? Induced EMF is equal to d by dt of n phi, rate of change of flux linkage, that is equal to E is equal to minus n d phi by dt. This is your induced EMF by statically induced EMF. So what is my negative sign? The negative sign is for Lenge's law, and it gives the direction of the induced EMF. The negative sign gives the direction of the induced EMF. This is all of the derivation of statically induced EMF. So there are two types of statically induced EMF. One is mutual induced EMF, another is self-induced EMF. Okay, so we will discuss self-induced EMF or mutual induced EMF. So पहले जानेंगे what is self-induced EMF. Okay, for that you will refer to this figure. There is a two coil. One is N1 turns, coil 2 is N2 turns. Okay, if you give the supply to the N1 turns coil, then if the change in current in one coil and induced EMF is the same coil, then it is called self-induced EMF. So मैं अभी क्या कर रहा हूँ, इसमें करंट चेंज कर रहा हूँ इस coil में, that is my I. If change in current in this coil and induced EMF is in this coil, then it is called self-induced EMF. So E self is equal to minus d phi by dt n1 phi. This is my equation. So minus n d phi by dt di into di by dt. So E self is equal to minus L self di by dt. So what is my L self? L self is equal to minus n d phi by dt. So this is the expression of self-induced EMF, that is E self, that is minus L self di by dt. So the self-induced EMF opposes the change in flux and current in the same coil by satisfy Lenge's law. So it is always opposes the change in current and flux by 90 degree. Similarly, for mutual induced EMF, if the change in current in one coil but induced EMF in another coil. So if I change in current in this coil but EMF is induced in the other coil, then it is called mutual induced EMF. So this is the expression of mutual induced EMF. E mutual is equal to minus n2 d phi by dt. So minus n2 d phi by di into di by dt. That is E mutual is equal to L mutual di by dt. It is also the mutual induced EMF is also opposes the change in flux and current of the coil 1 by 90 degree by satisfy the Lenge's law. So this is all about the principle of the transformer, working principle of the transformer, uses of transformer, and why transformer is necessary.